it gets skinnier. When the sample size is small, the standard error is large, and the sampling distribution is more spread out. When the sample size is large, the standard error is smaller, and the sampling distribution is narrower. So you see that as n increases, we have a smaller standard error, and we have a smaller interval in which we're pretty sure that the population mean lies. Remember that the mean of the sampling distribution is the same as the population mean. Specifically, we have to quadruple n to achieve half the measurement error. Let's explore this. Let's say that instead of a sample size of n, we use 4n, so we quadruple our sample size. This is the same as sigma divided by root 4 times root n, due to the properties of the radicals, and the square root of 4 is 2. So this is the same as 1/2 times our original standard error. So if we quadruple n, then we have half the measurement error. This isn't particularly important, but it's good to make a note of.